So today's video is going to be on the midpoint and the distance formula and looking at all the different things in the coordinate plane. One of your skills is being understanding the slope in the coordinate plane. So that's going to come up today as well. We're going to start off by just finding the coordinates of a midpoint in the coordinate plane. When you read a question, it's really important that you pay attention to the key words. And one of the most important words here is that it says it's a midpoint. As soon as you see that vocab word, think about what a midpoint means. A midpoint is the halfway point. It's the averaging. And that should hopefully give you a clue or a reminder of what the midpoint formula is. To find the midpoint, we take the x values, we add them up, and we cut them in half. That's going to find the halfway point. We do the same thing with the y's. We add up the y's, we cut it in half. Notice the little subscript 1, 2. That just means your first x, your second x. Your first y, your second y. Distinguishing between, so this is your first x, your first y, your second x, and your second y. It doesn't matter which one you decide goes first and which one goes second, as long as you're using the two different x's here, the two different y's here. So as we look at what we're given, we take our two x's, which are 6 and 3. We add them up, we cut them in half. We take our two y's, -1, and adding 9. We cut that in half. Again, I got the x's from here, and the y's are here. X is always the first coordinate, y is always the second coordinate. So 6 plus 3, that's going to give us 9/2. -1 plus 9 is going to give us 8/2. There's two different ways you could do this. You could leave it as 9/2, that's your reduced fraction. You could leave it as a decimal as well, only because 9 divided by 2 is exactly 4.5. 8 divided by 2 is going to be 4. So remember, the rule of thumb is you can write it as a decimal if it's an exact decimal. If you have to round to get there, leave it as a fraction unless the directions tell you go ahead and round. The second one, we're given 2 points. We are told F is the midpoint of GH. So we've got a segment here, and we've got our segment GH. And we are told that F is going to be the midpoint. Again, midpoint meaning that it's halfway, divides our segment into two equal pieces. F has the coordinates -1, 3, and G has the coordinates of 2, 5. In number 1, we were trying to find the halfway point between G and H. This time, I'm given the midpoint. My job is to find the end point. So I can't use the midpoint formula. I can only use the midpoint formula if my job is to find the midpoint. Right now, my job is to find the end point when I was given the midpoint. We're still going to think about those vocab words and what do they mean. Midpoint means halfway. So if I'm going from 2 to -1, I'm traveling from x to x. I ask myself, how do I get from 2 to -1? Am I adding or subtracting? I'm getting smaller. I'm going from a +2 to a -1. How much do I have to subtract to get there? So to go from 2 to -1, I have to subtract 3. That's my halfway point. Whatever I do to get there, because these two pieces are congruent, I have to move the exact same way to get to H. Halfway, same movement. Whatever I move from G to F, I have to move from F to H. So if I'm currently at a -1 and I have to move -3 more, that's going to leave me at a -4. Now that's just the x coordinate. Now I have to look at the y coordinate. I see that I'm at 5 and I'm moving to 3. So again, I ask myself, how am I moving to get from 5 to 3? I'm getting smaller, so I'm subtracting. I have to subtract 2. Halfway point, I move the exact same distance because midpoint means equal distance on both sides. I'm at 3. I'm subtracting 2. So 3 minus 2 leaves me at a +1. So our final answer here is going to be that the coordinates of H are at a -4, 1. When you are finding the midpoint, you use the midpoint formula. When you are finding the endpoint, the easiest way to do this is to use these jumps. You can use the midpoint formula. It becomes much more complicated and is going to be more likely for you to make mistakes using that method. So go ahead and stick to the jumps. Another thing in the coordinate plane we do is find the length of a segment. So we have our segment VH. Our coordinates are given to us. We want to find the length. The one formula that we know that allows us to find the length of a segment, besides just counting on a coordinate plane, which we can only count certain lines, is to use the distance formula. The distance formula requires you to find the change in y, square it, and then find the change in x, and square that. Now we say y2, y1, again, that's just distinguishing the fact that we have two separate x's and two separate y's here. So this could be our first x, our first y, and this is our second x and our second y. There's a lot of freedom here. You don't have to do the y's first. You could do the x's first. You could do y1 minus y2. It doesn't matter. You're just trying to find the change in. If you remember that from Algebra 1, the change in, you're trying to find the distance between the two. So you have to subtract your two amounts. This is the change in x squared. So let's look to see what we have here. So if I want to find the length or the distance of VW, I'm going to do y2 minus y1. So we've got a negative 3 minus 3 quantity squared, and then we add that to the difference of the x's. So 4 minus 2 quantity squared. We simplify that. We make sure that we simplify the entire piece inside before we evaluate that square root. So minus 3 minus 3 is going to give us a negative 6 squared. 4 minus 2 is going to give us a positive 2 squared. That gives us 36 plus 4, leaving us with the square root of 40. Right now we don't have to worry about breaking that down. We're just going to simplify it. So on our calculator we're going to do the square root of 40. And we find out that that's going to be about 6.32. When I do want you to round, I will indicate in the directions where I want you to round to. All right, our last problem, and this is a big one. We have this coordinate plane, and on the coordinate plane, I'm giving you 3 points to form our triangle ABC. So the first thing we do is start by making that triangle ABC. Negative 7, 2 is our point A. When you plot this point, the negative 7 is the x, so that's your horizontal distance. Because it's negative, we're going left 7. Y is the vertical change, going up 2. Then B is 5, 6. X is 5, which means I'm going right 5. Positive 6 means I'm going up 6. So to find the coordinates of B, we're going 5, 6. And our last coordinate is C. So we go right 5 and up 2 to C. Here is our triangle ABC. So we want to draw the triangle, which we did. Now we want to answer some questions. We want to find the slope of AB. You could use your slope formula, which is y2 minus y1 over x2 minus x1. Now, when you're on a coordinate plane like this, I just think it's easier to go ahead and count your rise over your run. If I'm going from A to B, I'm going up 1, 2, 3, 4. That's your change in y. And right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going up 4, which is a positive 4, right 12, which is a positive 12. So our slope is going to be 4 over 12, which is going to reduce down to 1/3. What is the perimeter of the triangle? Round to the nearest tenth. Now for this one, there is a long way to do it, and there is a short way to do it. as I look at this, I know I want to find the perimeter. So I'm trying to find the 3 sides added up. So I need to find the length of all 3 sides. As we learned before, there is a formula to calculate length. But don't create more work than you have to. When I look at this, I'm on a coordinate plane, so I can count if my pieces are vertical and horizontal. So from B to C, this is a vertical line. So I add to the count. It goes 1, 2, 3, 4. This has a length of 4. I go over here. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My segment AC has a length of 12. The only time I have to do more work is when I get to the length of segment AB. AB is a diagonal line. The only time you can count on a coordinate plane is if you have a perfectly horizontal line and a vertical line. If at any point it's diagonal, you have to use the distance formula, which we did right above. So to find the distance of AB, we subtract the y's. So again, if we want to look up here, here are the 2 coordinates. So our y's is 6 minus 2 quantity squared plus 5 minus a negative 7 quantity squared. 6 minus 2 is 4. Now, when we get to the next piece, 5 minus a negative is the same thing as adding. So that's going to give us a 12 squared. 4 squared is 16. 12 squared is 144. The square root of 160. Let's go ahead and round to the nearest tenth this time. So we get that it's about 12.6. Now that's just the length of AB. To find the perimeter is all 3 sides added up. So we have our length of AB, which is 12.6, plus the length of BC, which we found was 4 when we counted, plus the length of AC, which is 12 when we counted. So we add up all those 3 pieces to find that our perimeter is 28.6. All right, last one for this section. And this one is going to start breaking up into ratios. As we look at our line, on AB, that diagonal line, there are 2 points that divide the segment into a length which are in ratio of 1 to 3. That means that we have 4 equal parts. We have 1 equal part on one side to 3 equal parts on the other. 1 to 3. 1 on the left, 3 on the right. Or 1 on the right and 3 on the left. But all those pieces are equal. So 1 and 3, that gives us 4 equal pieces. To find out how we do this is we go up to the unreduced slope. So my unreduced slope is 4 over 12, and we found that by doing our rise over our run. We want to break that slope into 4 equal pieces. So I divide the top by 4, the bottom by 4. That gives me 1/3, which happens to be our reduced slope. It's not always going to be our reduced slope though. So when we go up to this segment, we use that slope of 1/3, go up 1, right 3, up 1, right 3, up 1, right 3, and up 1, right 3. So you see that we have 1, 2, 3, 4 congruent segments. If I want to break that down into a ratio of 1 to 3, let's imagine that we put our line right here. If I put my line right here, if I'm choosing this point, I have 1 equal piece, 2, 1, 2, 3. 1 on the left, and I have 3 equal pieces on the right. So this could be point P. Point P at the location of -4, 3. That point divides my segment AB into a ratio of 1 to 3. I could also go over here, and let's call this point Q. Now I have 1 equal piece on this side and 3 on this. So the point Q, if I choose this point, I have 1 equal segment here to 3 equal segments there. So these are the 2 points, and Q is going to be at 2, 5, that are going to break that line into a ratio of 1 to 3. It doesn't matter if the one's on the left-hand side of the line or on the right-hand side of the line. That's why we have two choices. All right, this last question with that whole slope coordinate, this is going to be a big question. So we're going to do this quite a few times. Make sure you get this down. Rewatch your video if you're still struggling on it, or come see me. All right, thank you.